Alright, so what does the minus 5 do?
Makes it go right.
Makes it go to the right. And what's the plus 6 do?
Makes it go up 6.
Makes it go up 6, so is it this one?
Yes.
Raise your hand if you got that right. Alright. Does anybody have a question? Don't just be a copier, okay? That's, you got, at least be wrong, you know, do something. Alright, now, which equation best represents the line shown on the grid? Here it is. So there's your graph. I wonder if y'all got tricked by this on the test earlier. I doubt it. What's the graph of a horizontal line? Y equals C, right? And so this one's going to be x equals c. That's a vertical line. Remember, a horizontal line is a function, and it has to be able to be written y equals, f of x equals. F of x takes the place of y, not x, right? Vertical line is not a function. If you guys remember, we evaluated functions and we substituted in a 2. Which one of these functions would I substitute in 2 and get 13 for my answer? Which one of these functions would I substitute in a 2 for x and get 13? You're welcome to use your calculator. Get 13 as an answer. Okay, can somebody tell me what they think? B. Because if I plug in 2, I get 3 times 2 squared plus 1, and that would be 4, and 3 times 4 is 12, plus 1 would be 13. That is correct. Just for practice. What would you get if you did here?
21.
Because 2 to the third is 8 times 2 is 16, plus 5. The ordered pairs in the set below are in the form x, y. In which set of ordered pairs is y a function of x? That's saying which one's a function. What keeps a set of ordered pairs from being a function? Yeah, if any of the x's are alike, then it is not a function. If any of the x's are alike, it is not a function. 1, 2, 3 are all different. Now, does it matter that those y's are the same? It does not. It's all about each element of the domain is paired with exactly one element of the range. Y'all remember the definition of a function? Hope so. Alright. If you need a calculator for this, I don't know. I hope not. What kind of equation is this since it's squared? Quadratic. So if I evaluate this at 0, what's my answer going to be? That's what it's saying.
0. B. Wait, what?
B.
They 1. Man, you guys need to get smarter.
And stop harassing.
Yeah.
Good deal. At least they go, I love zero, don't you? It works out good.
Some of it's
Works out really well. Let's try to divide by. Which graph does not, using the vertical line test, which graph does not represent a function? I would sketch all these and say yes or no beside them. If I were making out my study guide, I'd just do little sketches, little 4 sketches, little simple, not, little simple ones, and say yes or no.
C. D.
Which one's not a function?
A. C.
A.
D.
Let's think about vertical line test, vertical
It's
line
vertical
test,
X.
vertical line test, vertical line up.
I remember that percentage vertical is Y.
The others are yes.
God, I wrote them all backwards.
You got them all backward?
Yeah, I wrote
If a
no's and
vertical
yes.
line will hit more than 1 point, it's not a function.
Oh, I had 3 no's and.
What if it's a function?
Get that one right.
I'm sorry?
Function
Does
of
it
y.
ever ask if there's a function?
The vertical line test tells whether the graph that's given is a function. The horizontal line test tells whether its inverse would be a function without having to see the graph. So the inverse of this would look like this, would look like this one. But its inverse is a function. I can tell that without having to see its inverse. The inverse of this would not be, because it would be on its side. The inverse of this would be, the inverse of that would be. Very good question. Each of the following tables contains elements of ordered pair relationship. Which table contains 4 points that cannot lie on the graph of a function of x? In other words, which of these tables does not represent a function? It's the same idea that we had with the set of ordered pairs earlier. If the x's are repeated, it's not a function. So which table contains 4 points that cannot be a function? A, because of right here. This is not a function. See, these are different, different, different. These are all functions. Any questions? We're like a bunch of those, right? Tables, sets, graphs, mappings, we can tell that all day. And I hope that after the test today, you can look at an equation and know, thinking about the parent graphs, yeah, that's a function. Matter of fact, that's a quadratic function. That's a reciprocal or rational function. That's a square root function. That you would recognize those. That's the purpose of having that test today. Alright, determine which relation is a function with the correct domain and range.
I'm gonna say B. C.
See.
Jesus Christ.
This might have the correct domain and range, but it's not a function.
Oh, I didn't know.
This one is a function, and 8, 2, 1, 3, which we would have written 1, 2, 3, 8, I think. And then 3, 4, 9 are the relation.
I looked at the domain where it says domain, and none of those numbers were the same, so I just assumed that was it.
Oh, good point. Because when you write a domain in the range, even if the element of the domain occurs twice, you only list it once. So that's a good thought. You can't just look at the domain and range. You have to look at the table, the set, the graph, the mapping, the equation.
Is the domain on B swapped with the range?
I don't know. Maybe I hadn't looked. Oh, it is, isn't it?
Oh, see, that's what confused me.
I didn't even notice that. All right. So, let's see. 8, 1. This domain should be what? 1 and 8. And this range should be 2, 3, 9.
Let's just go to the next one.
That's all mixed up, isn't it? You think we have it fixed now? Just looking at it?
I think we should just go to the
Even-
next
I didn't
question.
think about
Because
it.
I didn't get this one.
Range.
Pardon?
How come A couldn't?
A cannot be because it's not a function, those two are, x's are the same, and the same thing here. But now that domain would have just been -4 and -5, listed those backwards. And the range would have been 2, 4, and 9. There's several reasons. Alright, determine which relation is a function with the correct domain and range again.
See.
Right, this is not even a function, this doesn't pass the vertical line test, that's not a function. These are functions, they do pass the vertical line test because you say, well, it goes right there, that's a hole, right? So that would just hit 1 point. The domain though would be all real numbers also, because even here is colored in. The range over here is just down at -6, the domain's all real, so yeah.
Wait, how would that be all real numbers?
How would the domain be all real numbers here? Oh, over here, because every X has a point on it, you know? Even this one, even though that's a hole, it's colored in somewhere.
How was wild remember?
Well, it's not either. The range, just on this part right here, is 3 and 5, so these are swapped. Yeah. Good question. Yes?
So it has to pass the vertical line test?
Yeah, to be a function. If it just said which graph has the correct domain and range, we wouldn't even care about that, but it really had more than that. What's a function and what's the correct domain and range? Alright. We are to find the sum function.
Yeah.
Okay? So all you do is add together. And then put your answer in descending order. So if you had F plus G, wouldn't you end up with D?
Yep.
Remember, those are kind of easy, add, subtract, multiply, and divide. Just have to watch your signs with subtraction and everything. Alright. Which is the subtraction? Which is the difference function? F minus G. Change our signs over here, and then we'll have a negative x squared, a positive x, and then 9 minus 3 is 6. Questions? Alright, the quotient function, F divided by G. This one's kind of mean. Alright, flashback. Factor this. Factor 81 minus x squared. Isn't that difference of 2 squares? Yes? And so it factors into conjugates, which are if I divided that by this, what happens? As long as x isn't 9, that works, because you can't have that down here. The domain of this will be all numbers except 9. Okay. Yes, ma'am.
Why did you do the non instead of 81?
What if we didn't
I
factor?
factored this, because it was the difference of two squares that factored into conjugates. It's kinda like, you know, reducing a fraction. You wouldn't leave this,
Oh, I didn't.
we
see that.
wouldn't leave that,
Mm.
we had to reduce it, because we know how to factor.
What if we didn't factor?
It's not up there.
It's not up there.
I got you.
And if it wasn't a multiple choice test, it would just be not simplified, you know. You got halfway home.
Just had it right.
Alright, fog and golf.
Nature.